Hey guys, welcome to question MM237 of the Maths Methods Fortify study guide. So we've got this question, pretty long, 12 marks. We've got this graph of f of x equals e to the power of x plus 1, which is f of x, this one here, and its inverse, y equals g of x, so this one here. Now, part A says, let k be any x point on the graph of f of x, and part I asks us to find the gradient of f of x at any point x equals k. Awesome. So, first things first is to find our actual gradient function, right? Because we're not going to be able to find the gradient if we don't know what the gradient function is. So we know that f of x is equal to, e to the x plus 1, which means that our gradient function is the derivative of e to the x is simply just e to the x, and the derivative of 1 is just 0. So our gradient function is just e to the x. Now, we're looking for the gradient at any point x equals k, which means that we're looking for when x equals k, our gradient is equal to e to the power of k, right? We just replace all our x values with k, which means that this is our answer. So our gradient at any point k is equal to e to the power of k, and that's our first and only mark for this question. So that's it. So let's move on to part AII. Part AII is a 2-mark question. Awesome. And it says, show that the tangent to f of x at x equals k is given by the equation y take 1 equals e to the power of k outside of x take k plus 1. All right, awesome. So we know that our gradient at any point k is equal to e to the power of k. So our gradient is e to the k. And in order to find the equation of a tangent, we're going to need to find a point on this graph, right? So a point on this graph is x, which is just the x value, and our y value is our e to the power of x plus 1, right? So e to the power of x plus 1. But if we're looking for the tangent at x equals k, that means our point is going to be k, e to the power of k plus 1, right? Because our x value is k. So in order to work out our tangent, we have y take y1 equals equals m outside of x take x1. This is the equation you should always use when dealing with tangent equations. Just makes it really easy. So we're going to take away our y value, which is e to the power of k plus 1. And that's equal to m, which is e to the k, outside of x minus our x1 value is k. Sweet. Now expanding all this out, we get y take e to the k, take away 1, equals e to the k x minus e to the k, k. Sweet. Now, just before we even go further than this, actually, this is our first mark. So our first mark is recognizing how to find the tangent equation with our x and y values and our m value, and then we can just keep going from there. So we need to think about what format we want this in. We're going to want y take away 1 equals something, right? So we've already got our y take away 1 here, which means we just need to take that e to the k over to the other side. So we get y take 1 equals e to the kx minus e to the k times k plus e to the k, right? So we're almost there in terms of our format that we want, but we can see that we're not actually quite there yet. So y take 1, that's fine, that's the left side that we want, but we can see here that we actually have a common factor of e to the power of k with all of these terms, which means we can take that out. So e to the power of k outside of x minus k plus 1. And this is our final answer. So that's where our second mark comes in. And you can even say at the end, like, as required. I personally really like the set, like, as required. You can also do QED, means the same thing. And that's basically saying, like, you would use that in a show that question. So you would get to that and then be like, as required, I've shown this. Cool, that's part AII done. So that is, yeah, we can move on to part B. So part B asks us to find the equation for g of x, where g of x is the inverse function of f of x. So part B is simply just 1 mark. Yes, we do have our calculator, so you can actually just solve this in your calculator, but I'm just going to do it by hand to show you how to do it. So we know that f of x is equal to e to the x plus 1. So we're going to let y equal e to the x plus 1. And then our working should be, I mean, it doesn't really matter because it's only 1 mark, but if this was 2 marks, you would say for inverse, swap x and y, solve for y. Because that's what we're doing. So we're going to say, therefore, x equals e to the power of y plus 1. X take 1 equals e to the power of y. Therefore, y is equal to x, log e of x minus 1. So therefore, g of x is equal to log e of x minus 1. And the biggest thing here is you've just got to make sure that you say g of x equals, because that's what the question's asking for. It's asking for the equation for g of x. If you leave it in y equals this, it's a bit iffy on if you would get the mark for that, but just make sure you say g of x equals that. So that's your first and only mark for part B. Let's move on to part C. Alrighty, so part C, or part CI, is a 3-mark question, and it is extremely difficult. So don't stress if you didn't get this. This is kind of one of those questions that's designed to be really, really hard, but we can go through it now. So 2 tangents are drawn to the graph of f of x at x equals a and x equals p, such that they are also tangents to g of x at x equals b and x equals q respectively, as shown on the axes below. So this is going to be very difficult for me to draw here, but basically we've got a line down here. It's going to be a tangent. Just pretend these are touching. I'm not going to be able to do that properly. So this is at q, so q, f of q, and this is at point p, p, f of p. Oh, sorry, g of q and g of p. Awesome. And then we've got another tangent that goes across like this to this graph over here, which occurs at b, f of g of b. Oh, this is going to be f of p. Sorry, this is very difficult to draw on a whiteboard. And then we've got a, f of a. Awesome. So, quite confusing. We've got this point in the middle, r. Sweet. All right. And the question asks us to find the values of a and b, correct the 3 decimal places. So, again, guys, very, very difficult question, so please don't stress out if you couldn't get it. But let's go through it now. So, 3-mark question, and we need to find this value here, a, and this value here, b. So we're actually not going to be using p and q in this question, so we can kind of just ignore those for now. But what we do need to do is use these points here to try and find a and b. So we know that the gradient at a is going to be the same as the gradient at b, right? Because they're both tangents to that point. So the gradient at this point is the same as the gradient at that point because it's on the same line. Which means that f dash of a, so the gradient at this point here, is going to be equal to the gradient of g at b. Right? Because they're tangents to this and tangents to this, so the gradient of those 2 points are going to be the same. Now, f dash of a is going to be equal to our gradient of e to the x plus 1 at a, which means our gradient of f at a is e to the a. Okay? Our gradient at x equals b of this, let's just jump over here for a second. Our function is log e of x take 1, which means that our gradient, so g and g dash, is equal to 1 over x take 1. That's our gradient of that. Which means at point B, our gradient is going to be 1 over b take 1. Okay? So this is our first simultaneous equation that we're going to need. Okay? So we're going to need to create 2 equations to find a and b. And you kind of just have, there's not really anything I can say that gives that away. It's really just, you kind of have to know that because you have 2 variables, you're going to have 2 different equations to solve for them. So this is your first simultaneous equation that we're going to need. And you also actually get your first mark here. So you get your first mark when you come up with this equation. Now, we also know that the gradient at this point A must be the same as the gradient of this whole line, which is rise over run between this point and this point, right? So our gradient at point A is e to the power of A. Actually, let's leave that out for a second. So we need to find the gradient between a and b and then equate that to this. So the gradient from a to b is y2 minus y1 over x2 minus x1, right, as always. Now, our y2, we're going to take b as our second point. Our y value at this point is equal to log e of x take 1, but because our x value is b, our y value is going to be log e of b take 1. Our y value of this point over here is going to be equal to e to the x plus 1. So f is e to the x plus 1. But because our x value is a at this point, our y value is e to the power of a plus 1. Right? Now, our x value at this point is b, and our x value at this point is a. Now, this is our gradient between these two lines, which is the gradient of the tangent, which means that this is going to be the same as the gradient just at a, which is e to the power of a. So therefore, e to the power of a is equal to this. So log e of b take 1 minus e to the a plus 1 over b minus a. This is our second equation. So this is our second simultaneous equation that we're going to need. I know this is crazy, and if you didn't get this, again, don't stress. Very, very difficult, but these are our two simultaneous equations, and now we can actually just put these straight into our CAS calculator because we have that. So what you're going to do is put in this equation. You're going to go into, I think it's menu 7.1 or something like that. No, menu 3.7, yeah, menu 3.7.1. You're going to put this as your first equation, this as your second equation, and you're going to solve for a and b. And what you're going to come out with is a equals negative 2.399 and b equals 12.016. Correct to 3 decimal places, that's what the question asked us for, and this is your third mark. So that's it for part CI. I know it's crazy, but just give it a go. And always remember that if you're trying to find two different variables, you're going to need two simultaneous equations. The only way to do that is to find the gradient between those 2 points, as well as at those points separately. So that's part CI. Let's move on to part CII. Part CII is a 2-mark question. Oops. Cool. And it says the coordinates of R, the point of intersection between tangents AB and PQ, where x equals R. So we need to find that, correct to 3 decimal places. Okay. So the coordinates of R are, actually, you know what, let's start with the equation of AB. So we're not going to be able to find R if we don't know the equation of one of these tangents, or both of them. So in order to find our equation for AB, according to part, what was it? Part AII, we know that the tangent to f of x at x equals k is given by y take 1 equals e to the k times x take k plus 1. But this time we're not dealing with x equals k, we're dealing with x equals a, right? Because this is a tangent to f of x at x equals a, which means our tangent at this point is going to be equal to y minus 1 equals e to the power of a, because this time our x value is a, x take a plus 1. And from our previous question, we know that a is equal to negative 2.399, which means that e to the power of negative 2.399 x minus negative 2.399 plus 1 is our tangent equation. Rearranging this, we get y equals 0.091x plus 1.309, and this is our first mark. Okay, so it's a 2-mark question. First mark comes when you figure out the equation of the AB tangent. Now, because AB and PQ are tangents to both f of x and g of x, the point of intersection is going to occur at the line of y equals x, right? Because they're inverses of each other. So because this is reflected over the y equals x axis, point R is going to have the same x and y value, okay? Because it's touching the y equals x line, right? That you can kind of see that's the middle point, which means that x is equal to y at this point, right? So if x is equal to y, that means we can actually just replace y with x and solve for x that way. Right? From here, we can solve in CAS, and we get x equals 1.439. All right, so because x and y were the same, we could replace y with x, and we know that this x value is 1.439. Now, if this has the same x and y value, then this is also the y value, so this equals y as well, which means that r occurs at 1.439, 1.439. And that is our second mark. Again, guys, very difficult question, but just try your best with it and see what you can do. But that's our final answer for part CII. Let's move on to part CIII. Part CIII, again, guys, is extremely difficult. And again, one of those questions that's designed to be super crazy. So this is a 3-mark question. We're actually asked to find the area of the shaded region. Now, I'm not going to draw the shaded region on this graph because it's just going to mess everything up. But basically, it's the area between all of this and this bit here. So enclosed by this bit here and this bit here. So what we need to recognize is that because these two are inverses of each other, this area is going to be the same as this area, right? So we're just going to deal with this top area, and then we're going to multiply it by 2 to let it equal the whole thing. So let's figure out this area up here. Now, it's not straightforward because we've actually got this graph that's going like that is bounding it, which means I'm just going to redraw this actually just to kind of show you exactly what's going on. So we've got this graph that's going here, and then we've got this line here that's coming down like this to here, let's say, and then we've got this other line going across here, right? So we're going to need to break this up into 2 sections. So this is our point R, this is our point A, this is our point P, and this is our line PQ, this is our line AB, right? So B somewhere over here, Q somewhere down here. So we're going to need to get this area, then add it to this area, right? Because this point here, it changes what the graph is bound by, or the area is bound by. So we're going to need to get the area, which is equal to this point here to this point. So this is x equals A, this is x equals R. So from A to R of this equation here, which is f of x, minus our equation for AB dx, right? Because when we find the area between 2 graphs, we do the top one minus the bottom one. Top one is f of x, bottom one is AB, okay? Then we're going to add this area here. So add from R to P of, again, from f of x minus our bottom function, which is our PQ, or our other line. So this is going to be our fundamental formula for our area. So if you're watching the video, guys, just pause it and write down this formula just so that you can keep track of what we're doing, and then we can move on. So I'm going to rub this out now just so that we can have some space. But what we need to do is, we know what f of x is. So just as I'm saying this, just look at the formula you just wrote down. We know what f of x is, we know what AB is, but we don't know what PQ is, right? Because we found the equation for AB in the previous part, but we haven't found the equation for PQ, so we need to do that. Now, first things first is we know that part A occurs at e to the power of a plus 1, which is negative 2.399 and 1.091, right? So we need to know this. We also need to know where B is occurring, okay? So B, and the reason we're doing this is because we know what A and B are, and we know how to find those points, and then we're just going to flip them to find PQ, okay? So B is equal to B log E of B minus 1, and that's equal to 12.016, 2.399, okay? So the purpose of doing this is so that because these are inverses of each other, this point here is an inverse of this point, and this point here is an inverse of this point, which means that for this and this, we can swap our x and y values to get these 2 points, all right? Which means that Q, being our inverse of this point here, is the inverse of point A, okay? Which means that Q, we get 1.091, negative 2.399, okay? So it's the inverse of this point here. And P is equal to the inverse of B, which is 2.399, 12.016, okay? So these two are like opposites, inverses of each other, so you can swap the x and y values and it gives you those. This is where our first mark is, okay? So finding P and Q gives us that. Now, in order to find the equation for P and Q, for PQ, the line, we're gonna need the gradient and a point. So our gradient is equal to rise over run, which is y2 minus y1 over x2 minus x1, right? So we get our first y value, 12.016, minus our second one, so minus negative 2.399, over first x value, 2.399 minus 1.091. What this ends up giving us is 11.016. So we know that this is our gradient of our PQ line, so this line here. That's a gradient. Awesome. If you're having trouble following along, guys, don't stress. This is a really messed up question. I can't even believe I wrote this. So we've got 11.016 for our gradient. And then, as always, to find the equation of the line, we need our C value, right? So we get y take y1 equals m, x take x1. We know that our m value is 11.016. Now we just need our y value. So I'm going to take, is that the p? 12? Yep, so that's our p value. So we get y minus 12.016 for our y value outside of x minus x1, which is 2.399 in our case. Rearranging this, we get y equals 11.016x minus 14.415. So this is our equation for PQ, right? So we haven't even started to do area yet. We needed this equation before we can even do that. So now, just looking back at your equation that you wrote down before, we have our total, or our top area, so this area up here, is equal to, from A to R, right? So A is equal to negative 2.399 to R, which is 1.439, which we found in the previous question, so part C, II, of f of x, which is e to the x plus 1, minus our bottom function, which is AB, which we found to be 0.091x plus 1.309 dx. So that's our first section here, just this bit, and then we need this other part as well. So we're going to add from R to P. So R is 1.439. P we found to be equal to 2.399 of, again, f of x, so e to the x plus 1, minus our PQ tangent, which is equal to 11.016x minus 14.415, as we found up here, dx. Awesome. And then from here, we can actually just put this in our calculator and solve it. Okay, so that gives us an area of 4.409 units squared. Oh, and also our second mark comes here. So when we write down this area formula, we get our second mark. This area, 4.409, is this top area, but we're looking for the whole area, which is including this one. And like I said at the start, because they're inverses, those two areas are the same, which means that we can simply multiply this one by 2. So our total area is equal to 4.409 times 2, which equals 8.818 units squared. Do not forget your units squared. You don't want to do all this work and then forget your units. So make sure you write that. And that's our third and final mark. Guys, I know this was messed up. I know this was crazy. So if you couldn't do it, don't worry. Just keep trying. This is designed to separate, the top students from the really top students. So that's it for MM237. Please hit me up if you have any questions in the comments below. Try and make them as specific as possible, because it's going to be hard for me to kind of determine what you're asking if you don't make it too specific to the question. So hit me up if you need to. But otherwise, thanks for watching. Hope I haven't confused you too much and scared you. But just have a go, and I'll see you in the next video.